like to show how to solve some word problems with that involve exponential functions. So an exponential function is going to be something of the form q of t equals to c e to the at. And it's important because many real-world quantities are described by this behavior. C, this constant, is the initial value, and A, which is this constant, is sometimes in compounding interest that will be interest rate, sometimes it will be the growth rate if A is bigger than 0, and sometimes if A is less than 0, it will be decay rate. Right. So in a word problem involving exponential functions, you will always have two measurements, and two measurements are enough to determine the whole function. Just like the straight line, because 2 points determine a straight line, 2 points also determine an exponential function passing through the 2 points. Let's see how. So let's suppose we have a problem like this. The population of a country X grows exponentially. Let's suppose this. It's pretty good approximation in many cases for some periods of time. And suppose country X has 10 million in 1960 and 20 million people in 1980. And you want to find the population of this country as a function of time. So because you know the population P of t, let's call this population of the country at time t, we know, or we suppose in the problem, that it grows exponentially. So we know it has this form, c e to the a times t. And then and t is the time in years. We will start counting time from the first measurement of this in 1960. So t equals 0 in year 1960, which means that we are interested in t equals 20 for year 1980, and year 2000 is going to be t equals 40. So what do we know about population? We know that in 1960, so at our time equals 0, we know this is 10 million. And we know in 1980, at time 20 years after initial measurement, we know this is 20 million. So these two measurements will be enough to find C and A, the unknowns in our function. Let's see how. So what we want to do is re-express this. So let's re-express this using the expression we have for the function p of t. So we'll be plugging in 0 in the expression for the population. We'll have c times e to the a times t, but t is 0, so 0 equals 10. And I'll rework this. So this is c times e to the a times 0. Any number times 0 is 0. So this is e to the 0 equals 10. But e to the power of 0 is 1. Any number to power of 0 except 0 is 1. So this is c times 1 equals 10, which means we have found our c. C is equal to 10. Now let's express the second condition. So we are plugging t equals 20 in the same function. So we have c times e a times 20 equals 20. But we know c was 10 from the first one. So we have 10 e to the a times 20 equals 20. We'll divide by 10 on both sides, and we'll get e to the a times 20 equals 2. Now this is an exponential equation, and we know how to solve it. We take ln of both sides. ln of e to the 20a equals ln of 2. ln and e go away, and I get, because they're inverse functions of each other, and I get 20a equals ln 2. And therefore, A is equal to ln2 over 20. This is an expression for A, which you can plug in your calculator. ln2 is about 0.69, so this is about 0.0345, or about 3.45% growth rate of this population annually. So now we have both C and A, and we can express our population at any time as being 10 times e to the 0.0345 times t. To solve part B, we just want to plug in 40 in our expression that we got. So this is going to be 10 times e to the a times 40. Now I don't want to write this 0.0345 because actually ln2 divided by 20 is more accurate number. This is just the 0.0345 is just an approximation of it. So I'll plug it in the original expression like this. I'll have 20 goes away with 40, 2 is left. So this is 10 e to the 2 times ln2. I can bring this 2 inside the logarithm in the exponent. So this is 10 e to the ln 2 raised to the second power. And e and ln go away with each other. I'm just left with 2 squared, which is 4. So this is 10 times 4, which is 40. So in year 2000, after 40 years, this country will have 40 million people if its population grows exponentially.